Hey guys, what's up? This is Steve here. Today let's go through another LeetCode problem called 1685, Sum of Absolute Differences in a Sorted Array. Let's take a look at the problem. You are given an integer array nums sorted in non-decreasing order. Non-decreasing meaning there could be duplicates, which means they will just be put in line. That's what non-decreasing means could be possibly be duplicates. So it's asking us to build and return an integer array result with the same length as nums such that result I is equal to the summation of absolute differences between nums I and all the other elements in the array. Let's take a look at what this means. In other words, result I is equal to the sum of the absolute difference between nums I and nums j, where j is greater than or equal to 0 and smaller than the total length of the index and total length of the given array nums. And j doesn't equal to I. It's 0 indexed. Alright, now let's take a look at example 1. Example 1 given nums 2, 3, 5 and output is 4, 3, 5. Why is that? How do we deduce the output from the input nums? So assuming the arrays are 0 indexed, let's see, result 0 comes from 2 minus 2. Why 2 minus 2? Because 2 is the current one that we are iterating. We're trying to compute the result for, right? 2 is the current element. So 2 minus 2, and then 2 minus 3, and then 2 minus 5, right? So we're using this element, the element we are trying to compute the result for, as the one to subtract it from the remaining elements. And then we take the absolute difference, right? So this is the 0, this is minus 1, but its absolute difference is 1. And then this is minus 3, its absolute difference is 3. So 0, 1, 3, it is 4. We do the same for the rest, for 1 and 2. So we got 4, 5, we got 4, 3, 5. This is how we reached this result of 4, 3, 5 from this given input. All right. Let's take a look at one more example. The second example, it didn't give us how the process of we reach the output from the input, but it's the same. How we use that is we use 1 minus 1 is 0. 1 minus 4 is minus 3, but its absolute difference is 3. And then 1 minus 6, and then 1 minus 8, and then 1 minus 10. We sum up all of the absolute differences of all of these. That's going to give us 24. So that is how we reached this conclusion. So the first idea that naturally comes to anybody's mind is to use the brute force way, which might work, but I doubt it because this one is marked as medium. So if you really use the brute force way, which is to calculate the absolute, just like the definition of this problem, we just iterate through the absolute difference and sum all of them up. That's going to give us the correct answer, but I doubt that it's going to be accepted on LeetCode because this is marked as a median. If we just use the brute force way, there's going to be a lot of repetitive summation, right? That's not ideal. Plus, it's just not the very way that we should aim for. We should try to aim for a more optimized solution. Okay, now let's take a look at the slides. We'll just use the second example because it has more elements. It has 5 elements as an example to see how we can optimize this solution, how we can build upon the brute force solution. So the brute force solution is we can just follow the intuition. We can have a nested for loop to go through all of the absolute differences and sum all of them up and then assign each of the summation result as the final output, right? So that's the brute force solution. So let's take a look at how we'll just break down this brute force solution and see how we can optimize on top of this, right? So we'll use the second one as the example. 1, 4, 6, 8, and 10. We'll use this one as an example. Let's see. So the result 1 comes from here, 1 minus 1 and 4 minus 1. So I'm reversing the order. Instead of 1 minus 4, I'm putting it as 4 minus 1 because I'm not putting them into vertical bars. This is just parentheses so that we get the positive result because this is the absolute difference that we care about with that we need to sum up, right? And then this one is 1 minus 6, but I change it to 6 minus 1. remember 1 is always here, right? Because we're computing the result for the first one at index 0. So then 1 minus 8, 8 minus 1, 1 minus 10, 10 minus 1. 0, so this is 0, 3, so 0 plus 3 is 3, 3 plus 5 is 8, 8 plus 7 is 15, 15 plus 9 is 24, right? So this is how we get to 24. We'll do the similar things for result 1. Result 1 is calculated this way, so we got 15, right? So 4, so this is the second result we're trying to compute for. So 4 minus 1, 4 minus 4, 4 minus 6, right? 6 minus 4, 4 minus 8, 8 minus 4, 4 minus 10, then 10 minus 4. So we get the absolute result, so that's 15. We do similar things for result 2, 3, and 4. So we use the similar processes we use the exact same processes to calculate the result for each of the elements. So here is the final result. So we have 24, 15, 13, 24, 15, 13, 15, and 21, 15 and 21, right? So now let's think about how we can generalize this formula. There's some regularity here, right? So how can we generalize this? We can put this as 1 or 4 or 10. This is the one that we are currently iterating on, trying to compute the result for. So that is nums I, right? This is nums I, and then this is nums 0 here. This is nums 1, right? This is nums 1, nums 1, nums 1. Then this is nums 2, nums 2, nums 2, right? The last one here, 10, 10, 10, is nums n minus 1. Right, so suppose there's a total of 5 elements. This one is at index 4, 5 minus 1, index 4, right? So here is our generalized formula, which is nums I, which is the one that we're currently iterating on, minus nums 0. Suppose I at this point is 1, so we have 1 here, and then we keep going on. Nums I minus nums 1, all the way until nums I minus nums I, right? At which point is this? Suppose I equals to 1, that is nums I minus nums I. That is here, nums I minus nums I. After this point forward, we just switch it up to use this one, nums I plus 1. You see, it's nums I plus 1 minus nums I. Then nums I plus 2 minus nums I. All the way up to the last element, which is n minus nums which is nums n minus 1, which is 4 in this example, right? Minus nums I. This is the generalized formula that we can get from this virtual example walkthrough, right? So now can we further generalize or simplify this formula? Is there anything we can extract from? Yes, we can, of course. So let's further think about it. Let's just further from another angle, from another perspective, we can take a look at this formula, which is there's nums I, a lot of nums I here, right? Nums I. We have a lot of nums I by summing them up. All of these, they are positive, right? But then we also have negative nums I. So how do we deal with this? If you take a close look, we can see there's nums I, nums I, nums I all the way to here. This one will cancel out with this one, so we don't need to worry about this one. So all we need to care about is all of these up to this point, and then from this point onwards until the last one. So how many I are there here? How many nums I are there within this range? That is a total of I nums I elements, right? Because from all the way from 0 to I minus 1. That means there's a total I nums I elements. So we can do a multiplication instead of adding them up, right? So the same goes for here. There's a total of nums. We'll cancel this one out, and then we'll start from nums I all the way. We'll start from I minus 1 all the way up to n minus 1, right? So how many negative nums I elements are here? There's a total of n minus I minus 1. Right? So now we have the multiplication formula for nums I, right? Let's try to further simplify this. The first one, this is the first range of all of the nums I. We get nums I times I, right? And for the second nums I, all of the negative nums I, there's a total of n minus I minus 1 nums I, right? And then with these two parts have summarized all of the nums I in this formula, then we're left with all of the non-nums I numbers in this formula, which we can summarize as well. So it will be two components if you look closely. So first, we'll just look at the signs of the rest of the elements. All of these, they are negative, right? So you see negative, or you can call it minus, right? This one will cancel out, this pair. And then all of these numbers are positive. So again, we'll divide them into two parts. One is all of these, they are negative, right? So we'll just minus them. But if we put all of them into parentheses, all of these could be added up, but it's just these need to be subtracted out from the final result. However, all of these positive ones, they need to be added up. All right, so that is, we can see, that is nums I, so we put a minus sign here, but all of these within the parentheses, we can add all of them up together. So 0, 1, all the way up to I minus 1. So here, 0, 1, all the way up to I minus 1. And then we'll add up all of these. This is add. All of these are positive signs, right? So we'll add up from nums I minus 1 all the way to n minus 1, right? I minus 1, I minus 2, all the way up to n minus 1. So this is the formula that we need. So with this formula, how can we reduce the repetitive computation of adding all of these numbers up? How can we do that? It's a trick, or it's a technique, or it's a technique that we use pretty commonly, which is to calculate the prefix sums or the postfix sums, right? So for example, here, nums I, nums 0, nums 1, all the way up to nums I minus 1. We calculate once, twice, 3 times. So if this is the case, how about we just calculate it once and store them in the temporary array so that we can avoid repetitive summation, right, or repetitive computation. The same goes for this. So basically, we'll use a prefix sum, which is presums. We'll just call it presums. And then this is post sums. And then each time, we'll just find the one that we're trying to iterate on. It's prefix sums and it's presums and post sums. And then we'll just deduct the presums and plus the post sums along with these two components. Then we can easily get the result. So now let's continue to use this example 1, 4, 6, 8, and 10. See how we can calculate the prefix sums and postfix sums. Let's see. So prefix sums, we'll just call it presums. So the presums, which means all of the sums up to this point, but not including this element. So the first presum is going to be 0, right? And then we'll just write that formula out, which is presums, which equals to all of the presums prior to this point. It doesn't have anything here, so it's 0, plus this one, plus this one's prior element. There's nothing here, so this one is 0. But next one, this one's presum should be what? It should be this one, because it's I minus 1, right? So this I is 1, so I minus 1 is 0, I minus 1 is 0, 0 plus 1, that's going to be 1, right? So this one is 1. We'll keep going this from left to right to calculate presums, but for postsums, we'll go from right to left. We'll talk about that in just a second. And then we'll continue to calculate presums. All right, so this one, what's presum for this? It's going to be this one plus this one, right? So presum I minus 1 is this, 1 plus 4 is 5. So how about this one? So it's 5 plus 6 is going to be 11. And then how about the presum for this one? It's 11 plus 8, it's 19. So now we have the presum. What does this presum mean? This presum means all of the sums prior to this current elements, right? So all of the presums all the way up to this point, not including this one, is 5. 1 plus 4 is 5. That's why this one is 5, right? And then we'll calculate post sums. Post sums will, as I just said, will start from right to left, because how we'll calculate the post sum is all of the post sums, all of the sums after this element, right? So for this element, it doesn't have anything on its right side. So we'll start from here, and its post sum is 0. We'll just write the formula for post sum as well. So it's the post sum all the way on the right of this sums plus its number, plus this number. So for this number, it doesn't have anything on its right. So 0 plus 0 is 0. But for this one, how about this? It's going to be 10 plus 0, so it's 10. Then how about for this number? It's going to be 10. It's going to be 10 plus 8, so it's 18, right? How about for 4? It's going to be for 18 plus 6, so it's 24. Now how about for this one? It's 4 plus 24 is 28, right? So this is the post sums. So now we can go back to this LeetCode problem. We can put the idea into the actual code, which is how we can get the absolute differences by using prefix sums, by after summarizing and generalizing the formula and calculating presums and post sums using 2 extra temporary arrays to hold them, to drastically simplify, to drastically reduce the time complexity of this problem. Now let's put the idea into the actual code. So first we'll calculate the presums, new int. Let's put length here. Length. All right. Length. Oops. I don't need this. Let's calculate here. Presums, post sums. We'll calculate presums here. We'll start from the left side, go all the way up to the right side, right? So we'll start from 1 because 0 is 0. It doesn't have any presums, right? I smaller than I plus plus presums. As the formula goes, how we calculate presum for I is presums. There is no typo, right? All right, yes. The previous one's sum plus this one is prior element, right? So with this way, we have calculated all of the presums of each element, and we are holding them into this temporary array. Now let's calculate the post sums. The post sums will start from the last element, the element prior to the last element, because the very last element is len minus 1, but that one is 0, so we don't need to do anything. Once we initialize an array, all of the elements are initialized to be 0. All right, now we have I minus and equal to 0, right? I plus plus. So how we calculate post sums is this. We just use this formula, post sums I plus 1, right? So it's the element on the right side, the sums of that and this element. So this is how we calculate the post sums. After this, then we can initialize the final result. We'll just use this formula, return result. How do we calculate the result? We can simply use that formula, which is result I equals to, there's a total number of positive nums I, and then we'll minus n length minus I minus 1. This one needs to be multiplied by nums I as well. And then remember, all of the presums needs to be deducted. Presums needs to be deducted, and then all of the post sums needs to be added up. Now let me run code to see if it works. Any typo or any syntax errors? It's accepted. Cool. Now let me submit. All right, cool. Accepted. 87%, 91%. Not bad at all. Let me just hit submit one more time to see if there's any differences. There could be. Not impressive at all. 55%. Okay, just one more time. Last time, I promised. It should be above 60%, around 60%. But anyway, this is the idea to solve this problem that can drastically reduce the time complexity from O(n) squared to only O(n) by borrowing extra memory. So this is a common strategy that, or a common trade-off. We sacrifice some extra space to buy in more time. We drastically reduce the time complexity from O(n) squared to O(n), right? So although there are 3 for loops, none of them is nested, which means it's O(n) time complexity, right? But we're using O(n) space complexity as well. We're using 2 extra memory, 2 extra array as the extra memory to help us speed things up. All right, this is the idea of solving this problem. I hope everything is clear. If you think this video helps you understand this problem and how you can approach this problem, please do me a favor and hit the like button. That's going to help a lot with the YouTube algorithm, and I really appreciate it. And don't forget to subscribe to my channel, as I have accumulated quite a lot of different LeetCode, data structures, algorithm, interview preparation videos on my channel, and also Amazon Web Services certification videos, how you can prepare and pass and get AWS certified. Those are very popular cloud computing exams. So hopefully I'll just see you guys in just a few short seconds in my other videos. Thank you very much for watching.